Can I ask you a question on the homework?
No. God.
So, one of them is like the square root of 4x minus 5. So how do you find the range for that again?
All right, so we have the function 4x minus 5, you said?
Yeah. And then I got the domain, which is 5/4 to infinity, but then I can't remember how to find the range.
Okay. So the domain is going to be 4x minus 5 greater than equal to 0. Just going over this really quick, just to touch back up on it. Adding 5 to both sides, then dividing by 4. So you said you got the domain. Cool. Now the range here is going to be asking the question, what's underneath this radical? Really, any number greater than 0, right? That's what this is telling us. According to this domain, as long as x is greater than or equal to 4 over 5, everything underneath the radical will be 0 or greater, right? And there's really nothing to stop any of those numbers from happening, right? It's not like we have 1 over x minus something or whatever, right?
Okay, so it would just be 0 to infinity then.
Exactly.
Okay. And then how do you know which subscript to put it in again? So like it has to be greater than or equal to 0, so it would be a closed bracket, wouldn't it, for 0?
Yes, for 0, it would be closed. So this is actually a great problem to start the lecture on, actually, just to reiterate some of those notations, right? So we've got the domain of the range that we just found. Now, let's put this in interval notation. The domain in interval notation is going to be over 5 to infinity, right? And the range in interval notation is going to be 0 to infinity. The reason for this is, going back to interval notation, we can rewrite each of these inequalities as an interval the following ways. Get everything? Almost. So we can write each of the intervals in the following way. Let me just check to make sure this is not muted. Dope, it's not. Awesome, all right. And what's happening here is in the inequalities, we're saying here that x can be up to a, but can't be a, and x can be up to b, but can't be b. And that's what the rounded brackets here mean. Similarly, in the second inequality, x can be up to a, but not a, but x can be up to b or b. And that's what the square bracket here is telling us. So what we're really saying is the rounded brackets mean you can go all the way up to that value, but you can't quite make it to that value, right? So we can get up to b here, but we'll never get to b. And what the square brackets mean is you can get all the way up to that value. So here we can get all the way up to A. And this is just the same idea as our less than or less than equal to, right? That's all we're really getting at. It's just rewriting these inequalities using interval notation or representing the less than equal to as square brackets, and the less than as rounded brackets. Everybody cool with that? Awesome. Now, coming back to the idea of domain and range, the domain of a function can be thought of in the following way. Let me write this out really quick. Got my really dope graph. Let's call that K. Let's call that C. Now, imagine that we've got a flashlight shining down into our function, right? The shadow cast by our function onto our x-axis can be thought of as the domain. So here, we have a shadow for every value except at c, right? So in that way, the domain of this function would be negative infinity, right, up to c, union with c up to infinity. Make sense what I mean?
Because it's excluding
C,
C.
exactly. We could also write this as the interval from negative infinity to infinity minus the single tone C, but without getting into too much set theory notation, this is sufficient.
So like, is there gonna be one on the test, like number 7, I couldn't even figure out, it was like find a domain and range and use a graph to verify, like it didn't even show you how to do it without graphing it, which I don't understand how to do that. Do you wanna look at the problem, like?
Yeah.
So like, I couldn't figure it out, so I clicked the watch it video and it doesn't like show you a way to solve it.
Okay, so what's happening here? Well, first, coming back to this and then back to
Yeah, that's fine.
Similarly, if we took and put, let's use a different color, let's use green. Took and shine our light perpendicular to the y-axis. In this case, you kind of have to imagine it in both directions, right? But in this case, we would have a shadow roughly through there, right? So let's say this is in, let's say this is in, then our range would be M to N, assuming that we actually read both values, right? Does that make sense to everybody? Yeah. Now, the way to find this algebraically, look for discontinuities in your function. So what I mean is your function that you had was f of x is equal to 4x minus 3?
4x plus 3, when
Plus.
x is less than 0. And then 3 minus x when x is greater than or equal to 0.
3 minus x when x is greater than or equal to 0.
Yeah.
Okay. First question to ask ourselves. Are either of these separate equations ever discontinuous? Another way of asking it is, are they always continuous? Well, they're polynomials, right? In the last lecture, we had a rule that said every polynomial is always continuous. So if this thing is going to be discontinuous ever, it's going to be discontinuous at 0. Does that make sense what I mean? So what that means is we need to graph these two to see what's happening. Or we need to check to see what happens when we put 0 in. And notice when we put 0 in here, we get 3. When we put 0 in here, we get 3. So automatically we know that they're not discontinuous at 0, right? In fact, these two functions are going to look something like this. That's going to be really steep. No, that's not going to be nearly as steep. So it's going to look something like this. So since this is always continuous, this is always continuous, and they are both equal to 3 at 0, we know that this is going to have a domain of, every real number and a range from 3 and above. Is everybody cool with that? Does that help answer your question?
Yeah, so the range is 3 above because if you plug in 3 equals 0 for both of them.
The range is 3 above because it is those, well, let me say it a slightly different way. If we were to consider every y output that we'll ever get, we will only get numbers that are 3 or larger. And that's why the range is 3 or above.
Okay,
Does that make sense?
yeah,
So the range will always be just those numbers you get out of your function. And that's why we can think of it as something like a shadow on the y-axis. Is that cool?
yeah, and then what was the domain?
The domain will be the same idea, but looking down at the x-axis. Notice we can put in every possible value of x that we want.
So it'd be 0, infinite, 0.
Well,
Wait, no, the infinity is, no.
we can put in whatever x value we want, right? So the domain here domain of our function is going to be from negative infinity to infinity. And the range of our function is going to be 3 and above. Now, question. If I got rid of that, what happens? So now it's just less than, it includes every value of x except for 0.
So then you would do the u, then it would be the,
Yes.
the-
Yeah, you have the right idea.
that's what I was just gonna ask. I was confused what the difference would be, but okay, that makes sense now.
So now, because we changed it here, now it changes a little bit down here. You can't put in 0 anymore. So 0 is not in our domain. But also, our range changes just a little bit too, right? What does our range change? What happens here? Well, 3 is no longer in our range because we can't put in a value that will give us 3, right? So we can evaluate this with a limit to show that our range goes up to 3. And we can evaluate this algebraically to show that our range does not include 3. Is everybody cool with that? So now our range would be 3 to infinity, both open brackets. Does this make sense to everybody?
Mhm.
Does that help answer your question?
Yeah.
Cool.
So, question with the brackets, is it always when they're not, when they're greater than or equal to or less than or equal to, is it always closed, it's always closed bracket?
If it has equal to, then it's the square
The
brackets.
square bracket, yeah,
If it does not have equal to, it's the rounded brackets.
always.
Yes.
It's, okay.
Yes.
I just make sure.
So,
That's what I
go
understood.
ahead. You remember
Well, I
that?
was just gonna say, I typed in the range as the square bracket 3 comma infinity open and it says it's wrong.
That's what I do. It's saying it's wrong.
Like, is that what it should be, right? Because it can include 3 since it's a greater or equal to.
Mm-hmm.
So,
Yeah, it's saying it's wrong.
this is what I erased because I know it's the right answer and it says wrong.
So let's check. Let's see what's happening here. Stop share.
Because it automatically includes
Mhm.
and it said it was wrong.
This is one of the reasons why,
It just includes the matching one and
this is one of the reasons why I give y'all so many,
Unlimited submissions or another one.
yeah,
oh, okay, I was like, you just, something happened with the projector, it was you.
that was me.
Yeah, I know, because I was working through it today at work, I'm like,
This was week 2, correct?
yeah.
Yeah,
Problem what?
7.
Was it the first six that we were working on last week?
This one,
Mm-hmm.
um,
That like we could know the second part wasn't matching up correctly.
yeah, and I never figured out that
Okay.
was so wrong for me.
Okay, that like was wrong
Because
to
we
me too,
couldn't do
and I
it
was like,
without graphing, right? Wasn't that what it was?
It's because I drew this wrong, and I didn't catch that before.
oh,
Yeah, I drew this wrong, I flipped these in my head. So this graph should be,
oh man,
that was on me. That was on me. I apologize, guys.
oh,
Should be like this. Trying to make sure these slopes were right.
But how's that change?
Well, now what are our y values going to be?
negative.
Oh,
Now it's going to be negative infinity instead, right?
Which one's a closed bracket? 3 is a closed bracket, right?
Right, they should be in this case. So that was just on me, the way I drew this up here.
this is gonna be a dumb question, but remind me how you figured out how to graph that one more time.
So first you look at the rules, right?
Yeah,
You
so,
decide, all right, which one comes first? In this case, x is less than 0, reading it left to right, we would say this is the first set of rules to apply.
okay,
Up until x is equal to 0, we would draw the graph 4x plus 3. So that's gonna look like a steeper line.
That was it.
Then 3 minus x, well, that comes from 0 on. So from 0 on, we have 3 minus x, which would be this graph.
Okay.
So that was on me. I drew that the wrong way. Got into too much of a rush and flipped it in my head. I apologize. Moral of the story, everyone makes mistakes, don't beat yourself up for it.